Hello and welcome to my YouTube channel. Today we are going to see how to toggle an LED on the Tiva C board using GPIO interrupts. So let's start the video. We know that on Tiva C board we have three user LEDs which are RGB user LEDs and two user switches, switch 1 and switch 2. So in this project what we are going to do, we are going to toggle the red LED which is connected at PF1 port F's first bit and using PF4 which is switch number 1. So remember we are going to write a program to toggle the LED which is connected at PF1, the red LED, using the switch 1 which is provided at the PF4 or port F's fourth pin. Before going to the program, we must know how the LEDs and switches are connected. So here we can see LEDs are connected at port F 0. We have the switch number 2, PF1, red LED, PF2, blue LED, PF3, green LED, and PF4, switch number 1. But more important is that when the switch is open, by default, here you can see the switch is generally connected to 5 volt, and the moment we press the switch, when the switch is short circuited, the voltage at the port or the pin goes to 0 or ground. So the moment we press the switch 1, the voltage at PF4 will go to 0. So we will make the program accordingly so that when the switch is pressed, the LED should toggle. Now let us briefly understand the concept. So we have the port F. To activate the port F, we have to first provide the system clock using sysctl, and providing the clock will activate the port F. By default, all the peripherals in the Cortex M4 microcontroller or Tiva C's TM4C123GH6PM microcontroller are deactivated to save the power. To activate them, we have to first provide the clock using sysctl, which is system control block. Then after providing the clock, we have activated the port F. Then we will write the code to read the status of PF4, that is connected to switch number 1, and based on the status of the PF4, we will toggle the red LED which is connected at PF1. Okay, here we are not toggling the LED just by reading the status, rather we are looking at the GPIO interrupt to toggle the LED. So we will be toggling the LED based on the interrupts occurring at GPIO port F4. So these are the steps to be followed. First we have to provide the clock or the system clock for the gating circuit of the respective port, which is port number F. Then we have to configure the pins of the port such as switches as input and LEDs as output. Then because we are using switch, we have to enable the pull up or pull down register so that the terminal is not floating pin. So by default, the switch terminal will be either in the 5 volt or 0 volt. When you pull up the switch, the by default voltage will be 5 volt. Now then after that we have to attach interrupt to the pin of the GPIO. Then we will read the status of the switch, and based on that interrupt will be generated from the GPIO input pin. There is a small concept of key debouncing which we have to manage, because whenever we make a press, generally the mechanical switches generates multiple switching instances, and to avoid multiple reading we have to manage the key debouncing, or we say the function related to key debouncing. And let us see how we can write the code in the Code Composer Studio using TivaWare library to toggle the LED using GPIO interrupt. Okay, so let me start the Code Composer Studio. It may take few seconds to open the Code Composer Studio. Now click on New Project, or you can go to File and New and CCS Project. These two ways you can generate the project. So I would prefer to go with Start New. Click on that. Here in the target you have to type TM4C123GH6PM, which is the microcontroller present in the Tiva C board. Then for the connection between the board and the PC, we have to use Stellaris in-circuit debug interface. And let me give a name to the project, GPIO underscore interrupt underscore LED underscore toggle. And then empty project with main and finish. With this, the Code Composer Studio will generate a basic program for us with the main. So let us compile it and check if there is any error. So the build is finished without any problems or errors. Okay, so let us start coding the program. Before that, we have to, let me just close this project. Let me remove it. Okay, let me delete this part. And now this is our project. So right click, go to properties, and then include options, and click on add. And this is what we have been doing since last 4 or 5 projects. Go to C folder. If you have installed the TivaWare, then you can open the TI folder. Inside that you will find the TivaWare C series 2.2.0.295. If you have not downloaded it, I would recommend it to download and install it before writing the project. Select the folder and click OK. And then apply and close. So in this way we have added the TivaWare folder. Second job is to add file. Go to C folder, then go down to TI, TivaWare, go to driver lib. Because we are using Code Composer Studio, open the CCS folder. Inside that, open the debug folder and choose the driver lib.lib, which contains all the library related functions. So in this case, we are getting a message, select how the file should be imported. I prefer to go with copy files. This will copy the driver lib.lib file in my project folder. Okay. So we can see here driver lib.lib has been added to our project. And now we can start writing the code for our project. So let us first include some basic header files. Standard control space will allow you for auto filling. So standard int.h and then hash in control space and then standard bool dot h, and then we can use hash include, use control space for autofilling. Okay, inc, then hardware memory. This contains all the peripherals address and details of pins of the TivaWare TM4C micro TM4C 123 GH6PM microcontrollers details. Now include hardware types SW. Let me check. INC SW types, because TivaWare supports both the Tiva C series, which contains TM4C123GH6PM, or we can say Texas Instruments TM4C123 and TM4C129 series. So to include both features, we are using hardware.types.h. Then we can use include inc include folder. Inside that we have to use interrupts. So sw underscore int interrupts.h, which contains all the details related to interrupts. And then we can use the peripherals. So hash include driver lib. In this folder, we have to select first sysctl, which will provide the clocks to the port F. Then we will use include driver lib. Then because we are going to use GPIO, for that we have to include GPIO.h. Then we have to include driver lib. Inside that we have to use pin map.h, and then the last header file is include driver lib and interrupt.h. Okay, so these are the header files which we will be requiring to write the program. Now let us start writing the program for us, for our system. So first of all, we have to provide clock to the port F. Or we can say this will be used to activate the port F. So for that we have to use sysctl. Okay, so before going to write the program, what we can do is we can add the .c files related to the peripherals, like first of all GPIO.c, come down sysctl.c, and then let us check interrupt.c. So these three files we will include so that we can use the functions in these files directly. Open that, copy the files to the folder or the project folder, and here we can see GPIO.c, interrupt.c, and sysctl.c has been added to our project. And then go to view and click on outline. So here you can see the outline window which shows all the functions which have been used in the project. So let me just open the sysctl.c, and here in the right, in the outline window, we can see all the functions which are available in the sysctl.c file. So first of all, we have to set the clock. So sysctl, and this will set the clock frequency of our microcontroller. So we will use this function sysctl clock set, and you can read the details. So this function sets the clock of the device, and we have to provide four parameters. First one will be the division factor for the clock, which will be division divided by 1, divided by 2, divided by 2.5, 3, and so on. Then we can specify the crystal frequency that we are going to use. Then we can specify whether we are going to use main or the PLL, and so on. So let me just use that function and then populate the arguments. So copy this function and then paste it here, semicolon. Now we have to populate the arguments. So first argument will be, let us go and copy the first argument, which will be, we will be using sysctl divided by 4, or we can keep it sysctl sysdiv 1, so that divided by 1 will be there. Okay, now we have to use the features related to PLL or main. So here we are going to use PLL, or you can use oscillator main also. In my case, I am using PLL. Okay, here should be OR operation. Okay, then OR. Third argument will be whether we are using main crystal or so. So we are using main crystal. So copy this, paste, and then we are going to run our system or the microcontroller at 16 megahertz. So let me just check. 8 megahertz, 8 megahertz, and then 16 megahertz. I'll copy this and paste it here. So we have included the system clock and we have set the clock for the microcontroller. Now let us enable the port F using sysctl. Okay, so here we should write set the clock frequency of the microcontroller. Okay, now let us enable the peripheral port F. So for that we have to use the function sysctl peripheral enable. So here sysctl peripheral power enable. Okay, so let us read about this function. So it enables a peripheral, and here are the list of peripherals which can be enabled using this function. So let us copy this function, paste it, semicolon, and provide the argument. The argument for this function can be any argument that is provided in this list. So we are interested in port F, so we will copy this sysctl peripheral GPIO F. So this will activate the port F. And remember, port F we are activating because the switch and the LED of the Tiva C board are connected to port F. Now we have to configure the PF1, okay, which is connected to red LED, okay, PF1 pin as output pin. So to configure the GPIO, let us open the GPIO.c file, and in the outline let us check how can we configure the pin as an output. So for that we have to check GPIO pin, and we have to configure it as an output. So GPIO pin type GPIO output, this function. Here you can read this function configures pins for use as GPIO outputs. Yes, we are interested in configuring the pin to work as an output. So copy this function and paste it with semicolon. Now here we can see there are two arguments. First argument is the port address. Second argument is the pin number. So to provide the port details, what we can do is we can check the list of ports which we can put and the pin number. So these ports details are provided in the main function. Let me go to the pin map. Okay, just open the declaration. Right click, open the declaration. Yes, and because the program is too large, you can give 50,000, and you can here we can see all the list of names of the ports. Okay, let me close this. Rather, I will work with the hardware memory map. Let me check what are the details here. So here are the port bases. Okay, so we can use GPIO port F, AHB, which is high speed bus. Rather, we can go with normal bus. So GPIO port F base. Okay, remember this port F's detail or the port F's address, all the details are provided in the hardware memory map .h. Okay, so we can copy this variable which is the port F's address. So go to the main and let me define a variable. So that define uh, red LED as a GPIO pin, and for the port I can define let me first define the switch rather than red LED. So define port underscore F, port F as port F base. So first argument should be the address of the base. So port address. So I can use port F here, Control C, and here I can put port F. Second detail is regarding the pins that we are going to use. Okay, so let me just check if the pins detail are provided in the memory map. No, pin details are not provided. So open the GPIO.c file and let us check if the pins details are provided in this file. No. So let me check another header file which is pinmap.h. Open that. And let me check the GPIO pins variable name in this. It is a very long file. Rather, let me close this and check if I can find the variables for the pin. Okay, so let me just use red underscore LED and GPIO autofill function. I will use GPIO and control space and use GPIO pin 4 because pin 4 GPF 4 is connected to the switch. So GPIO pin 4. No, we have to use red LED. So pin 1. So let me use this variable which is connected to the pin F1. Okay, so we have defined the variable for port F, for the red LED, and for the switch we can use define switch underscore 1 GPIO underscore pin number 4, because PF4 is connected with the switch. So let us configure the switch as an input. So we have configured the red LED. So configure the PF4 as input pin, and this is for switch 1. Okay, so let us open the GPIO.c to find the function which will make the pin input. So here we have the GPIO pin type GPIO input function. Copy this function and let us read about the function. Configures the pins for use as GPIO inputs. Let us paste it here, semicolon, and let us fill the arguments. Again we need the port address, so let me just write port F, and then here we need the pin details. So switch SWI switch 1. Okay, because we have declared switch 1 or defined GPIO pin 4 as switch 1. So you can either use GPIO pin 1, GPIO pin 4, or rather give it a better name and use them. Okay, now we have configured the pin as an input. Second job is to provide the pull up register functionality. For that we can use GPIO pad config. So GPIO, let me check, GPIO pad configuration. So for that you can go to GPIO pad config set. Now let us read the functionality here. This sets the pad configuration for the specified pin, and it requires 4 arguments, which is related to the port, the pin, the current strength. Strength means here it means the current that is allowed to flow in the pin, and then the pin type. Remember, the GPIO pins can support 2 milliampere, 4 milliampere, 8 milliampere, 10 milliampere, and 12 milliampere. So we can configure them using these arguments. Second, related to port, we have to define the port, which is port F. Pin, the pin which we are using for the switch. The current we can get from this, and then the type. Okay, so type can be standard, pull up, WPU means word pull up, and then pull down, analog functionality, wake up high, wake up low. So we are interested in this function, which is pull up. Okay, so let us copy this function. Let me just copy this function and use it in our program. So copy this function and paste it here. Okay, so we have to fill 4 arguments here. Let us fill them one by one. So first of all, the port. We know the port is port F. Okay, then we have to specify the pin. So the pin is switch 1. Now the strength, for the strength we can go to the GPIO.c file, copy the strength, because we are not interested in providing too much current. We can use 2 milliampere. So copy that function variable and paste it here, GPIO strength 2 milliampere. Last is the pin type. For that we know we have to use pull up functionality. So GPIO pin type standard pull up. So here copy that and paste and semicolon. So we have configured the pin as an input pin with pull up functionality. Now after this we have to enable the interrupt for the PF4. Okay, so enable interrupt for pin number 4, or we can say switch 1. Now to enable the interrupt we have to use GPIO's interrupt feature. So go to GPIO.C and first enable the interrupt at the GPIO pin. So GPIO int enable function will help us. Let us read the functionality. It enables the specified GPIO interrupts. So to enable the interrupt of the GPIO, we can use this function. And how many arguments are there? Two arguments. First is the port number and then interrupt flag. Okay, so we can use the second interrupt flag means which pin you want to use. So out of these pins we can specify. Okay, let us copy this function GPIO int enable, copy this and paste it here, semicolon. Now to enable the interrupt, again we have to provide the port name. So port, we know that port F, and for the interrupt flag or the pin on which we want to use the interrupt, so we know it is switch number 1. Okay, I am using control space to autofill the variables. Now we have to tell the system which type of interrupt or triggering is going to take place. In the beginning I told you the switches are generally connected to the pull up. That means the pin will be always high, and when we press the switch the terminal will go to ground. So that means we are interested in falling edge. By default the pin will be high. When we press, the voltage goes to 0. So that is falling edge or falling voltage. So let us open the GPIO.C file and set the triggering type. So interrupt type set. So we have to check the interrupt type. Okay, so GPIO pin, GPIO int type. Okay, so int type set. This function will help us. So let me read the functionality of this function. Sets the interrupt type for the specified pin. So what are the types of triggering that it supports? Falling edge, rising edge. Rising edge means when the voltage goes from 0 to high, or both edges. That means when the voltage goes from high to low, or vice versa, low to high. And GPIO low level, that means when the voltage level is low, continuously it will generate interrupts, and when the pin is continuously high, it will generate continuous interrupts. We are interested in falling edge. Okay, now let me copy this function, control C and paste it here. So it requires, we can see 3 arguments. First argument is the port, then the pin number, and then the type of triggering. So let me just fill the port, which is port F. Port F. The pin is our switch. Okay, so switch 1, and type is falling edge. So we can copy the argument from here, falling edge, GPIO falling edge interrupt. So copy that. Now we have enabled the interrupt for the pin, and let us enable the interrupt at the end. So we have configured the interrupt, and to enable the interrupt we have to go to interrupt.c file and just check. So int enable. So we have configured the interrupt, and now we have to enable the interrupt. So we will use int enable function, and we can see it enables the interrupt functionality. So we have to specify the peripheral which will be used for the interrupt in the argument. In our case it is the interrupt for port F. Okay, so let me copy this function and paste it, semicolon. So in the argument we need to specify the interrupt. So we are interested in the interrupt and the port F. Okay, so how can we get the type of interrupt? For that we can use this header file swints. Open that file and come down to see which kind of interrupts we can use. So here we can see, come down in the bottom, you can see int GPIO f. We will be using this argument for our function. Okay, so first of all we have to copy the function. So this is int enable, copy that function and come down to the main. Okay, we have pasted it. We need the argument. For that we can open hwints.h. In the bottom you can see int GPIO f. So interrupt enable in the port f. So control V. So we are able to get interrupts from the port f. Now just to enable the interrupt in the microcontroller, to enable the interrupt of the processor, we can use another function which is int master. Let me show you that. So in the interrupt.c, you can see int master enable function. This function enables the processor interrupt. So let me just copy that, and it does not need any argument. Copy it, paste it, semicolon, and remove the void feature. So this is, and now we can write while 1 here. So remember, in the while 1 we are not writing anything. Okay, so because we are going to toggle the LED using interrupt, the while 1 loop will be empty and the interrupt from the GPIO will toggle the LED. So now we have to check how to write a function, or which function will enable the interrupt handler. For that we can use interrupt handler, and that detail is provided in the startup file. Remember, all the handler related functionalities are provided in the startup file. So tm4c123 gh6pm startup underscore ccs.c. So if you come down, you can see here all the list of interrupts which are available on the different peripherals, like timer related interrupts, PWM related interrupts, ADC interrupts. But here in this file, all the interrupts are provided the same name. So whenever the interrupt will come, it will go to this name. So you can see here in the bottom, whenever the interrupt will come, we will be coming to this function. But we are not interested in this function because we are interested in the interrupt generated from port F, and then we have to write our own interrupt functionality. So first let us check where the port F's interrupt is. Here we have the GPIO port F interrupt. So we have to give a different name here. So let me give it a name here. I will delete this name. Rather, I will use GPIO underscore F. Sorry, GPIO F underscore handler. I will use this function or this variable name to generate the or handle the interrupts. Okay, and because we have created this handler, we have to in the top we have to give the prototype for the handler. So we have to use extr and extern function, because this specifies that the definition of the handler is not present in startup, rather somewhere else, which will be in our case the main function. So extern void, our handler is GPIO underscore handler. Okay, and can provide void. So now let us take this handler function and put it in our main function. So these two changes you have to make in the startup. First is give a different name for your port F's interrupt. In my case, I use GPIO underscore F handler, and then created a prototype. Okay, and using extern function. So extend means the program or the function is defined somewhere else. So we will define it in our main function. So in the main function, we can write void GPIOF handler, okay, and then it is not going to return anything. So void curly braces started and closed. Now, whenever the interrupt is generated, the microprocessor will come to this function and try to execute whatever is written within these two brackets. So first thing that we have to do is whenever the interrupt is generated, first clear the interrupt. So let us go to the GPIO.c, and here there is a function called GPIO int clear. So let us read the function. It clears the specified interrupt sources. So whenever the interrupt is generated, first thing we will do is to clear the interrupt, or to tell the processor that the interrupt has been cleared. So next time again the interrupt can come. So copy this, Control C, and paste it in the handler function. Inside that, now we need the port detail. We know port F. So port F is there, and int flag we know that is the pin which is providing the interrupt. So switch is the int flag. So we have cleared the interrupt, and now wait a second. Let me take this semicolon back. Okay, and now we have to read the status of our switch and then toggle the LED. So for that, let me just make a variable or declare a variable that is volatile. Volatile means it can change due to external factors. So bool, because there are two states, low or high in the switch, so I am going to use bool, and I will use LED state is equal to false. First I will keep that false. Okay, and now use that variable in my handler. So LED state is equal to toggle, or just complement the LED state. Now if the LED state is high, okay, if the status of the LED is high, what we need to do is to make the LED low. Let me just open the GPIO.c and use the write function GPIO pin write, okay, to write the pin as low. So it writes a value to specified pin. Let me copy this. We have used it earlier also to toggle the LED. So GPIO write, and it needs three arguments. First is the port. So here we will use the port F. Now the pin which has to be toggled, which is our red pin or red LED, which we have already defined in the top, and the value. Value means it can be 0 or 1. Okay, so we can read it from here. The value can be 0 or 1. Okay, bit 0 or 1. Now what I can do is I can just use red LED. Okay, that will make the LED high. If the status of LED is high, we'll make it high, and then else we can use GPIO write, copy and paste it here, and make it low. To make it low, we just provide 0. So what will happen when, if the key is pressed or the switch is pressed, interrupt will be generated, and when the interrupt will be generated, the program will come to this handler function which we have defined, and then in the handler function we will first clear the interrupt which was generated. Then we will change the status of LED variable. LED state variable, and then if the LED state is high, that means we will make the LED high. If it is low, we will use the low. One more important factor, I told you that whenever we press the switches, they make multiple contacts and we call them key bouncing. To avoid key bouncing, we can use a simple approach. First simple approach is to generate a delay after any key press. Okay, and we call it software delay. So introduce a delay to handle key bouncing. Okay, bouncing. Okay, for that we can go to sysctl.c, and sysctl provides a by default function called sysctl delay. Okay, so let me check sysctl, come down and let me check if sysctl delay is available here. Come down. Okay, let me check sysctl delay, RAM, peripheral, sysctl delay. Why it is not available here? Let me just check again. Sysctl deep sleep reset delay. Sorry, I was missing it here. So sysctl delay function. So let me copy this function and use it in our program. Okay, so go to the main. You can use sysctl control space and let us check delay. Here you can see in the bottom, and we have to provide a value in milliseconds to generate the delay. So let me take 15,000 just for trial. You can change this value to meet the requirements of key bouncing. So this has to be changed according to our board. So we have to keep on changing and check whether the key is bouncing or not. So let me just compile this program. So we'll go to the hammer and click the hammer, compile it, and we can see there is only one warning which says this statement is not reachable. Yes, this statement will not reach because we are here in the while loop. So I can just comment this part or keep it there with the warning. So no such big issue. And here with the flash, we can just load the program and start the program in the microcontroller, or we can use debug mode. Since I have taken too much time in this video, I will go with the flash to show you how the interrupt will toggle the LED. So let me just open the camera. I believe now you can see the camera on top right, and let me flash the program. So click on this flash button and it will load the program to the microcontroller. Okay, the program has been flashed, and let me check if the LED is blinking with the keys press or not. So you can see the LED is toggling with the press of switch. Okay, and here also you can see with every press the LED is not toggling perfectly, and this issue is due to key bouncing. So for that, what you need to do is you have to play around with the value provided in this function sysctl delay to further optimize the program. With this, I would like to end the presentation because we have taken too much time in this video. If you have not subscribed the channel, then I would request you to please subscribe the channel and press the bell icon so that you can be notified with the latest videos uploaded by me. If you have any doubts or any suggestions, please use the comment section to put your doubts and suggestions for the videos. Thank you for watching the video and have a nice day.